We will be talking about some geometry concepts here, largely working with triangles. So where I always like to start with this is to talk about the vocabulary of what we're measuring, as well as any formulas and the meanings of those formulas. So in this case, for area, we are talking about the inside part of a shape. So because we'll be talking about area of a triangle, I'm going to just go ahead and draw that. I always tell my students this is not an art class, so bear with me, and nothing is ever drawn to scale. So there you go, not an art class. All right, so that said, let's say that this is a right triangle. So that little box means a right triangle. Okay, and a right triangle means that this is 90 degrees. So just a little vocabulary there. All right, so now that we've mentioned that, visually, what the area is the part inside the triangle, right? Like we've talked about perimeter before, and that's the distance or addition of all of the sides. The area is the part inside those sides, okay? So the formula here for a triangle, right, is 1/2 base times height equals A, or BH, so base times height divided by 2 equals A. This format is actually the one that I tend to use the most. You can use either. It's absolutely fine. Some I think are easier to use under certain contexts than others, but as you practice and learn, you'll figure out which one you like best and when. So what does that actually mean? Well, when I was learning this stuff, I had the worst time remembering that formula because I had known the formula for the area of a rectangle, area equals length times width, for quite a while. And then they threw this one in, and it felt totally new, and I could not remember it. So here's what I realized that helped me actually remember this formula. Okay, so here's a rectangle, right? All right, so remember that variables are just letters that stand for numbers that we don't know. So variables are interchangeable as long as you define what they are, okay? So in the past, we've talked about length, right, times width. And then area of a rectangle, I'm going to put a little rectangle here. So that's called a subscript, and those can be labels. So I know that with this little label, I'm talking about the area of a rectangle. And then I'm going to use this to then say, okay, but now I'm going to talk about the area of a triangle. So that can be really helpful for an organizational thing. All right, just a little something I use. So the formula for this is length times width. Well, if this rectangle is length times width, again, not an art class, okay? And then I shade this part in. Notice that is a triangle. Well, what portion of that original rectangle is the area of that triangle? I just cut that rectangle in half. So the area of the triangle is the area of the rectangle divided by 2, right? So that is where the area formula for a triangle comes from. I found that to be super helpful. So just remember, area of a rectangle divided by 2. Now, notice we have BH over 2. So for the triangle, we talk in terms of base times height. But again, they're interchangeable, right? So you could use WL, you could use BH for both of them. It doesn't matter. Okay, so the next formula is volume. Volume of a rectangular prism. And you can think of that as a box. That's kind of the simplified way of thinking about it. A rectangular prism can sound like a big thing, but it's just not. As usual, I'm going to go ahead and draw a picture. I'm going to draw a picture of a rectangular prism. Okay, and so we have a length, width, height. And the thing to remember is because the formula for the volume of a rectangle is all multiplication, the order doesn't matter, right? Because of the commutative property of multiplication. So the thing that can be hard to remember when working with volume is that the unit will always be cubed. So remember, area, we're multiplying two things. So let's say our unit is in feet, right? For area, it's going to be feet squared. For volume, if we have feet, we're multiplying three things together. So it's cubed, or at least that's what I use to help me remember, okay? All right. So when you're working with a triangle and finding the area, remember the area formula is area equals base times height divided by 2. So we have to know what the base is and what the height is to find the area, or we need to know the area and one of those sides to be able to find the other one. So how do I identify what the base is and what the height is? All right, so in a triangle, there are two ways that you will see your height indicated. In a right triangle, which is one that has one of these little boxes, right? And that means 90 degrees. That also means, and this video is not going to go into this, but I just want to mention that the side opposite, oops, that's a U, the side opposite the 90-degree angle is called the hypotenuse. The base and the height are talking about these two sides. Again, because of multiplication, they are interchangeable, okay? So here, the height is always going to be the length vertical, or the vertical portion of that 90-degree angle, okay? So this right triangle, 90-degree angle is the biggest one in the triangle. The vertical part of that angle is your height. Now, for a non-90-degree triangle, okay, so notice that box is not there. I look at all of those angles and they all look to be about the same size. That just tells me it's not a right triangle. That means to find height, you will have to be given an indication of the height. Okay, so you would have to be given an actual dimension for it. So I don't know, just for kicks, let's do like 10 meters. And then you would have to do for your base, let's say that's, I don't know, 12 meters. How about that? Okay, so I know that this distance, because it's got the 90-degree relationship with the base, is my height. Okay, so it's really important to make sure that you're comfortable with identifying what your height is. Okay, so knowing all of this, let's then go to actually trying this. So it says find the area of the triangles. Okay, so I have my shape and I have what I'm solving for. That tells me the formula that I need. So I know automatically that it's A equals base times height divided by 2, or 1/2 base times height. Now I have to figure out what my base is and what my height is. Well, here's that 90-degree angle, which means this is a right triangle. So I know that the 7, right, is my height. So that equals h. Well, I know that being a right triangle, the side opposite that is not my base, right? That is my hypotenuse. So that does not matter. I don't use that in this calculation, but the 24 inches is my base. So once I've identified all of that, I can plug the information in, right? A is what I'm solving for, so that is the variable that I'm going to have. And then I put 24 in for my B times 7 in for my height. And I divide by 2. Okay, so I took each of the values, right? I substituted them appropriately into my equation and got what I was looking for. Okay, so now I'm ready to simplify. In simplifying, I need to simplify my numerator, and I get 168 over 2. Okay, I know that because the denominator is a 2 and the numerator is even, I know that 2 goes into 168. So I'm going to go ahead and divide by 2, and I get 84. And then you have to include your units because 84 doesn't give me any information. It's a number, but we are actually looking for a specific measurement, right? Well, the measurement is in inches, and the measurement we're looking for is area. And we know that 84 inches squared is area because inches is a squared unit. So don't undervalue the importance of units. It's how you get the meaning of your answer within an application problem. Okay, so let's do another one. So this one is not a right triangle, right? So let's kind of look at both of those together. My height is the dashed line. I do have the little indication of 90 degrees, which I need to be able to know that it's height. All right, so I know I'm finding the area. I'm going to do area equals BH over 2. Now I'm going to go ahead and plug in the values that I'm given. So I have area equals base, which is 11, times height, which is 8 over 2. Now I simplify the numerator and I get 88 divided by 2, and then 44, and again, inches square. And that is your final answer. Now, I kept saying, okay, the formula, right? I know that I need to find or use this formula because I'm finding the area of the shape. That's true, but you know you need to use the area formula anytime area and triangle is identified, because you're going to use that formula also if you're finding a missing side. So I always key in on the shape and the dimension that they're looking for, or the dimension type, right? Is it area? Is it perimeter? Is it volume? So I draw my shape, or I look at my shape and write whichever formula I have to use. So thinking of it that way helps me make sure that I stay organized. Okay, so for 2A, we have the area of a triangle is 24 units squared. Find the missing side. All right, so we have area and we have triangle. Well, the area is 24 units, right? Units squared, that's just the unit. We know that area equals 24, and we're looking for a missing side. Okay, so when I look at that, I see what I'm given, and I see what I'm solving for. So area equals base times height divided by 2. I already know that I've been given the measurement for my area. I don't include units in my calculations because units can feel an awful lot like variables when they're actually in the equation that you're working with, and it can make it far more confusing. So that's why you don't see me writing units as I go. I will add them at the end. All right, so I was given area. I was also given my base, right? And I'm looking for my height. And notice they've used the variable x for that triangle. You can switch the formula to include x if you want, or you can keep it as h. It doesn't matter, okay? So my base is 8. I'm going to stick with this because you're going to see it more often, but if you want to switch that to x, you absolutely can. So I have BH over 2. All right, so this may look a little funky. Yeah, funky happens, especially as you're moving forward in concepts, right? This is area we've learned long ago, but now how we're working with area changes. Looking at this, where you have a combination of an integer, right, the 8, with a variable in the numerator may have your brain a little uncomfortable. So what I want you to remember is when you are looking at something that has a variable connected to it, I only pay attention to the numbers to start. And I'm going to look at that as, okay, what is 8 divided by 2? So I have 24 equals, well, 8 divided by 2 is 4. And then that h just goes along for the ride. It doesn't actually impact your calculation at this point. Now I'm ready to get the h by itself, or x if you decided to switch to that variable. All right, so I'm going to divide by 4, right, because I need to cancel multiplication. So I have to divide to be able to cancel that, and I do it to both sides. That goes away, and I get h equals 6, and it's units squared. So you could write it as units squared. That's shorthand, or you could go ahead and write it the way that it's written right here. So the missing side is 6 units squared, and that is your final answer. So I've been having this conversation come up multiple times recently, and that is about the impact of anxiety as you are working through problems. The more stressed you are, the more anxious you are, the more tired you are, right? It impacts what's called your working memory. Well, your working memory is responsible for problem solving and recall. Often what I find is as my anxiety goes up, my organization of my brain kind of goes away, right? I may be able to look at a triangle and an area, right, and have a nice path that I'm following. And then anxiety hits, say, during a test, and all of a sudden I look at them and they feel totally disconnected. My brain does not know what to do. So I tell people, when you're practicing so that when you're at a test, it will automatically happen, follow your first thought. Whatever your first thought is, do it. Okay, because often we actually know what we're doing, but our working memory is impacted negatively because of the stress that we're under. So as you're practicing, think, what is my first thought? And do it. What is my first thought? And do it. The other part about practicing is don't care about whether your answer is right or wrong while you're doing it. Just do it. I know that sounds totally counterintuitive, but that's the only way that you're going to actually start trusting yourself, right? Where you do something, and if you do it and you do it right, yay, that's great, right? But if you do it and it's not correct, you've already practiced the, okay, I'm going to trust myself. Well, if it's wrong, that just means you have something to review, right? And it helps inform how you're going to review. So I mentioned that because the most recent conversation I had about this was around the area of a triangle. So go with your first thought. Okay, now we have the area of a triangle is 60 feet squared. If the height is 12 feet, what is the base? So I want you to go ahead and pause the video and try that strategy of do your first thought. The instant your brain starts trying to get you to do something else, stop and go back to that first thing. Okay, and then turn the video back on and go ahead and follow my steps. All right, so the area of a triangle is 60 feet squared. So area and triangle, right? Those are important things. And then I have 60 feet squared. And notice is means equals, right? So I've got a little equation that is getting set up here. So the area, well, I'll go and read the second sentence. I always say that I just do one read through and then I go back and start breaking it apart. I kind of didn't do my full read through, so I'll do that now and then we'll go ahead and continue breaking this apart. So it says if the height is 12 feet, what is the base? All right, so I already identified the important stuff here. Area of a triangle, well, that is length times, nope. Okay, no, actually, this is what I'm going to do. So previously I used base times height, right? But I've also said the variables don't matter. So I'm going to go ahead and use length times width just to show you how you actually get to the same thing. So then I'll do it again using B times H, and I'll tell you when, at least if I'm grading stuff, where I prioritize making sure the variable's the same and whether it's different. So, okay, here we have length times width divided by 2 equals, well, we've been given 60 feet squared, so I'm going to put 60. Again, no units at this point because it's not my final answer. If the height is 12 feet, height, so at this point, you need to identify, well, if we're using L and W, which one stands for height? And let's say the W does. So that means that the 12, right, goes into W. So you just need to define the meaning of your variables. They didn't say like find H. They just said find height. Okay. So 12, so I remember, I'm going to go ahead and use the unit in my labeling, but again, I won't use it as I'm solving. And then it says, what is the base? Well, if W is H, then L is B, right? Okay, so I now have, let's see here. So I have 12L divided by 2 equals 60. So notice how I flipped, where I was saying that W is the height, it's 12. So I put that in, but I ended up flipping that numerator, right? So if I had written it the way that it was originally written, it would have looked like this. And that looks confusing because coefficients, right, integers that are connected to variables are in the front. So the top way, the L times 12 divided by 2, is not wrong. However, your brain may look at that and say, oh my gosh, I've never seen that before. I don't know what to do. Well, you're right. Maybe you haven't seen it that way. And that's okay. You can rewrite it into a format that you are more familiar with. And again, because of the commutative property of multiplication, you can make that switch. Okay, so just something to be aware of there. All right, so remember in the previous one that I did, I said, well, we've got two numbers, right? One of them is sitting next to a variable. So I'm going to run the calculation 12 divided by 2, which is 6L equals 60. And now I divide. Divide by 6, divide by 6, and L equals 10 feet. And it's a singular unit because it is just a dimension. It's not a perimeter, right? It's a length that you're dealing with instead of area or volume. So, okay, so because I said that I'm going to go ahead and also show this to you, so the calculations will be the same, but now I'm going to go back to B times H over 2 equals 60. I'm going to try to demonstrate to you that, yeah, it doesn't matter what variables you use. Now, again, if it specifically said, what is H, right? What is height H? Then you would need to use H for height. What is base B? You'd have to use B and so forth, but it's not defined that way here. It just says, what is the base? It doesn't say what variable goes with the base. Okay, so I'm going to do the same thing here, right? I'll go ahead and do sort of the uncomfortable format first, and I'm going to do B times 12 divided by 2 equals 60. But that looks really uncomfortable. So again, if you don't like that, go ahead and flip it like I did before. 12b divided by 2 equals 60. And also notice I can write it without that multiplication symbol, right? Because a number sitting right next to a variable means multiplication. So the bottom way that I've written this, the 12b divided by 2, is the way that you will have seen things most often and what you will continue seeing moving into the future. Okay, so now I just focus on the numbers that we know, which is 12 divided by 2, which is 6b equals 60 divided by 6 divided by 6, and b equals 10. I'm almost out of room, so 10 feet. And that is your final answer. Okay, so let's go to C. So this one's a little bit longer, right? But what I'd like you to do, it has a combination of things, okay? I see both, just at a glance, the term perimeter and the term for area. So you've done both of those things for shapes, right? You've done them for rectangles and squares. You've done them for triangles. Remember that the perimeter is just the sum of all sides. And then area, right, for a triangle is base times height divided by 2. So go ahead and pause this, try it on your own, and then come back and see what I do. The reason I want you to try this one before you watch the video is because it's a combination of skills that we've been working with. So it will give you a sense, if you can sit down and do these calculations within a slightly different context, it means that you have a pretty good understanding of what we're doing. If you're not sure, it just means that you need to go in and do some review about perimeter, right, and area. So it's a great way to measure where you are at the moment for your understanding. So go ahead and pause it, give it a try, and then turn it back on. All right. So the perimeter of a triangle is 36 meters. All right, triangle, 36 meters. The base is 9 meters, and the height is 12 meters. What is the length of the missing side? And what is the area of the triangle? Now, I marked the question marks. I love using question marks for helping me see whether I have answered everything that I need to answer. So in this case, there are 2 question marks. That means there are 2 questions that I need to answer. So I'm going to split those. Now, one answer may be dependent upon another, right? Like you need to use that answer to find the other, but you can still break them out into individual calculations. So rather than paying attention to both question marks, I'm going to just focus on that first one. So based on the information I've been given, what is the length of the missing side? All right, so I know that P of a triangle equals A plus B plus C. That is looking at a triangle like this. Okay, and I've used A, B, and C here because when you start working with regular formulas for triangle, like the Pythagorean theorem, if that's something you've heard of before, and if you haven't, it's totally fine, but it uses A, B, and C for your triangle. So usually when I'm talking about perimeter of a triangle, I use A, B, and C to start familiarizing you with those variables related to a triangle. All right, so the perimeter is this. Well, we've been given, right, what the perimeter is. So this becomes 36 equals A plus B plus C, right? Now this says the base is 9 meters. I'm going to say that's 9 meters. That's my base. And then my height is 12 meters. What is the length of the missing side? All right, so that is the first thing that I'm trying to find. So I'm going to say that this is A, this is B, oops, well, there we go, that's better. That's B, and then C is what we're trying to find. All right, so now I plug in what I'm given. 36 equals 9 plus 12 plus c, right? Now I'm going to simplify the right-hand side, right? Because now I'm at the point of needing to solve. So to solve, the first thing I do is simplify both sides of the equation. Well, there's nothing to simplify with 36. And I get 21 plus c. Now everything is simplified on each side of the equal sign. So now I need to combine like terms across the equal sign. Well, I do that by the opposite function, right? Now the opposite function is for adding and subtracting really the opposite sign of the number that you're moving. So since we have a positive 21, we need to take away 21. And we do that from both sides. I'm out of room here. So 36 minus 21 is our next calculation. And I get 15 equals C. So 15 meters, right, is my missing side. All right, so I'm done with my first question mark. Now, what's the second? What is the area of the triangle? Well, area, and it says what is the area, so that's what we're trying to find. So that's our variable. And then we have, let's see, I'll do base times height divided by 2. So again, right, we have this is one side that we're dealing with, and this is the other side that we're dealing with. Ooh, there we go. Okay, so we have area equals, I'll call 9 meters as my base, times height is my 12 meters, divided by 2. All right, so now I simplify, right, which I'm multiplying the numerator. Okay, and I get 108 divided by 2. And then I need to divide by 2. And that gives me 54 meters squared, right? Because it's an area calculation, so my unit has to be squared. All right, now I want you to notice we found perimeter first, or we were given perimeter, and we used that to find our missing side. Then we found area. Well, it turns out that from the beginning, we had all the information we needed to find the area, right? Because the two sides that we had been given were, let's see, I'm going to change color because why not, right? So we were given this measurement and this measurement. Those are the two measurements we need for area. So we could have calculated area first. Now, if we had been given C, right, and not given one of the other two, then we would have had to have solved the perimeter question first and then used the result to find our area. So it's just important to be aware of those things, right? This case, we already had the information we needed to find the area. Other times, we won't have enough information. We have to do something before we can find either answers that we're looking for. All right, so now I'd like you to go ahead and pause the video and try D. Now, this is pulling on knowledge that we have about mixed numbers and multiplication, right? Because the formula for the area of a triangle uses multiplication. You cannot multiply with mixed numbers. So I'm going to just make a note that step 1, again, when doing area or volume, right, because they both use multiplication, you have to convert all mixed numbers to improper fractions. So we're using this skill of conversion in a different context that we haven't done before. Okay, so convert mixed numbers to improper fractions. Once you've done that, then go ahead and do what we've been doing related to area. Okay, so hopefully you paused the video, you gave this a try, and now I'll go ahead and do it. All right, so here's my read through. A triangular pan has a base of 6 2/5 inches and a height of 2 1/3 inches. What is the area written as a fully reduced fraction? If you have a problem that starts with either integers or fractions or some combination of that, your answer has to be written as an integer or a fraction. You cannot use decimals. You can't use decimals while you're solving, and you cannot create decimals at the end. So be really careful with that, okay? So let's see, triangular pan. So I'm going to go ahead and draw a triangle. Now I didn't specify a right triangle, but I'm just trying to show visually what this question is telling me. And so it doesn't matter whether I do this or whether I do a triangle with that line that goes from the top down to the base. Either way is totally fine. I'm just representing the problem. Okay, so it has a base of 6 2/5 inches. So B equals 6 2/5 inches and a height of 2 1/3 inches. Okay, and that is my height. There we go. Now I have to convert those first. So I have 5 times 6 is 30 plus 2, which is 32. So I get 32 over 5 inches. Then I go up here and I do 3 times 2 is 6, plus 1 is 7, and I get 7/3 inches. All right, so now I'm set to start running my calculations. So I'm looking for the area of a triangle. So area equals, we'll go ahead and do base times height divided by 2. Notice how every time I'm doing these problems, I write the formula. I encourage you to always do that, and it's critical for when you're learning, right? When you're trying to remember what these formulas are, write them every single time, because your brain eventually will remember it, because it just can't not if you do it enough. All right, so let's see here. We've been given, so area equals 32 divided by 5, right? That's my B, times my height, which is 7/3. And then it's divided by 2. Ooh, that looks really ugly, right? So let's make it look less ugly. All right, and here's how we're going to do that. The very first thing I'm going to do is combine my numerator. Now, it's multiplication with fractions, so I always say, see if there's anything that can be reduced before you multiply. And in this case, there isn't, right? 5 doesn't go into 32, 3 doesn't go into 32, either of them go into 7, so there's nothing I can do except multiply across, okay? So I get 32 times 7, and that gives me 224 over, 5 times 3, which is 15. And then I have this 2 down here. The line right here means division, right? So you can always rewrite something that looks like this as the whole thing that's on the top, which is what this is, divided by 2. Now we have a division problem. We did before, but it looked really ugly, right? And what is it telling us to do? So now we can do put the whole number over a 1, because we always have to do that when we have a combination of fractions and whole numbers. I'll switch away from orange because, whoa, that could get a little annoying. Anyway, so we have 224 divided by 15. Change the division to multiplication, and then you flip the second fraction. All right, now we're ready to start our calculation. So can we cross cancel? Well, yeah, we can, because we've got 24 right here that's divisible by 2, and we have a 2 right here. So 2 goes into 2 one time, and 2 goes into 224 112 times. All right, so I don't see anything else. Well, let's see. Let's test something. We've got 112 and we have 15. So this is, I'm going to put a little note that we are testing if fully reduced. So I just want to show you a strategy that I use if I'm unsure whether something is fully reduced or not, because here, right, it says that it needs to be written as a fully reduced fraction. I am much more familiar with the factors of 15, right? What numbers multiply together to get 15 than I am the full list of 112. So here's my list of factors of 15. So 1, 2 doesn't go in, 3 does go in, 4 doesn't go in, 5 goes in, okay? And then there's no other number except for 15 that goes in. So we only care about whether any of these numbers go into 112, okay? And I'll show you why that is in a moment. 1 is going to go into anything, so it doesn't actually impact anything. That's why I'm not testing that one. But let's do our 112, because again, let's see, we have 112 over 15, and we're trying to see if anything can be reduced out. So 112 divided by, I'm going to go ahead and check 3. I'm going to go ahead and check 3. Okay, and that does not give me a whole number. So I know that 3 is not able to go into 112. I also know 5 can't go into 112 because 112 doesn't end in a 0 or a 5. 15 doesn't go in, but what if you're not sure? Okay, just go ahead and run the calculation, right? 112 divided by 15, and if you get a whole number, great. If you don't, which you won't, but if you do, right, great. If you don't, it just means that you are already fully reduced. So by doing it that way, identifying the factors that I'm more familiar with, like I did with 15, right? I got my short list and only had 3 values to double check instead of working with 112 and figuring out all the different factors that go into 112. I have found that to be a great strategy for making sure things are reduced and not taking forever to figure that out. Earlier, we talked about the formula for the volume of a rectangular prism, which is a box, basically just a pretty name for that. The formula for the volume of a rectangular prism is length times width times height. So notice it's area multiplied by one more dimension, right? By the height. Okay. That orange, whoa, that could be wild if I use that too much. All right, so we are switching from orange. So find the volume of a box with a width of 10 inches and a length of 24 inches and height of 15. I like to draw my pictures. Eventually you may get to the point where you don't want to, or you don't need this, but I really encourage you to do it as you're learning these things. And if you're consistently getting them correct, then go ahead and drop drawing the picture and see how you do. But man, having that visual connection between what the problem is saying and what you're needing to do makes all the difference, at least for me, and I know for many of my students as well. All right, so we have, I'm going to say this is my width, this is my height. Nope. Well, no, I'll call it height. That's not originally what I was going to say, but that's fine. And then this is my length. Again, interchangeable, right? Because of the commutative property in your equation is all multiplication. So it's a great example of don't stress about identifying what is width, what is length, right? Because it doesn't matter. All right, so now I'm going to, I call it plug and play. So here's my formula, right? I'm solving for volume, and I have that my length is 24 inches. So that's 24 times my, let's see, my width, which is 10, and my height, right, which is 15. Now I just need to multiply all those things together, and that will give me the volume of this box. Commutative property, right? Doesn't matter the order. I'm going to go ahead and go left to right, because with order of operations, that is often the most forgotten thing when you have an equation or an expression that just has multiplication and division or just has addition and subtraction, right? You have to go left to right. Great way to practice that this here, even though you don't have to. It's not absolutely necessary in this context. So 3,600 inches cubed is the volume of the box. All right. So this one, go ahead and pause the video and actually try both of these. I just saw a little typo, and that typo is that should not be cubed, because that is just a length, right? The only way that it would be cubed is if I had given you a volume. So as you're watching here, I'm going to actually delete that. There you go. Now it's correct. So that's a great example of how you really need to look at what you have on that unit to make sure that it's correct for the type of measurement that you're being given. So, all right, on that note, again, try B and C on your own, and then go ahead and restart the video and see what I do. Okay, so here's my read through. Find the volume of the rectangular prism with a length of 2 1/3 inches, width of 13/14 inches, and a height of 5 inches. Rectangular prism tells me which volume formula I'm going to use. Length times width times height. And because it's multiplication, think about those fractions. We cannot have mixed numbers, right, when we're using multiplication. So we know that mixed number, 2 1/3, is going to have to get converted. One generalization that I usually follow is that I just convert my mixed numbers to improper fractions, because I can always use improper fractions, but sometimes I can't use mixed numbers. So always converting to improper fractions will get me to the format, or have me in the format that I can always use. That's just kind of my personal rule that I've developed over the years. Get things into forms that can be used all of the time, not just some of the time. All right, so let's do that conversion. So 2 1/3 inch, we've got 3 times 2 is 6, plus 1 is 7, right? So my new fraction here is 7/3 inches. So I have a length, 7/3 inches. I have a width, 13/14 inches, and a height, 5 inches. So remember, not in art class, not drawn to scale. I'm just drawing it out so I can have a visual of what I'm actually working with here. All right, so because we're finding the volume, V is what's going to stay as my variable. So I get V equals, because the variable indicates my unknown. It's the thing that I'm trying to find, okay? So let's see here. Let's say my length is 7/3. 7/3. I'm going to use parentheses to indicate multiplication, because for me, it's just easier to see. You could use your dots also, but do not use X's. We are beyond those because it could cause a lot of confusion. Okay, and then times 5/1, right? Because it's a whole number in combination with fractions. All right, we are multiplying fractions, so we need to cross cancel. So I have 7 and 14. So 7 goes into 7 one time, 7 goes into 14 twice. Now, I don't actually see any other numbers that can be simplified out, so I am now ready to multiply across. So I get 13 times 5, okay, which is, 65, over 3 times 2, which is 6. There's no indication of the format of the answer, I don't think. I'm going to go double check that though, because it's always really good. So it just says find the requested information. It doesn't say that your answer has to be a mixed number, right, versus an improper fraction. So you can just leave your answer like this. I will do, just for a little review of mixed numbers, the conversion here, because it's always good to have a chance to go through something that's maybe on the newer side to us. So I write it as 65 divided by 6 because that's what this means, right? Well, 6 goes into 65. Let's see, 6 goes into 6 one time. So I get 6, subtract. I drop the 5 down. Well, 6 goes into 5 0 times. So I have 0 and 5. So my fraction is 5/6. So my answer is 65/6 inches cubed, or 10 and 5/6 inches cubed. And that is your final answer. All right, so for C, our one read through, so the volume of a box is 162.5 inches cubed. Find the width if the box is the length. If the box has a length, there we go, has a length of 10 inches, right, and a height of 4 1/3 inches. All right, I see two mixed numbers there, and I see volume. So I have to convert those, right, before I do anything else. So there's my formula. Now, 162 1/2. Well, to convert that, I do my denominator 2, right, times my 162. That gives me, so this calculation is 324 plus 1. So I get 325 over 2. That is my volume. If the width of the box is 10 inches, so that one is in a format that I can already use, equals 10, and height equals, let's see, so 3 times 4 is 12, plus 1 is 13, so I get 13 over 3. Now I look at my formula. Remember, variables are interchangeable. So I've been given my volume of 325 over 2. That equals, well, I've got 10 times, now let's see, they gave me height, but again, this is all multiplication, so it can be written in any order. So I'm going to go ahead and do 10 times my 13 over 3. And then that equals my, let's see, well, width is what I'm solving for. So I'm going to put W here. Okay, and I'm going to say that W equals width. And just so I'm consistent, I'll put a dot right there. Okay, so when I get my W by itself, I will have solved for width. All right, so now what do? Well, we need to put our whole number over 1. Now we look to see if there's any reduction that we can do using cross-canceling, which in this case there isn't. You also can't go straight up and down in a fraction, so we have to go straight to multiplying across. So I get 325 divided by 2 equals 10 times 13, which is 130, divided by 3. And then I still have that W sitting there. All right, not pretty but that's okay. One step at a time. So we've got two ways that we can get a variable separated from a fraction. I'm going to go ahead and do the multiply by the reciprocal strategy. So the reciprocal is the flipping of the fraction, and it's the fraction next to the variable that we have to work with because that's the one we're trying to get rid of. All right, so I like to use my distributive property structure to remind myself that whatever I do to one side, I have to do to the other. So in this case, my reciprocal is 3 over 130. If I do that to one side, I have to do it to the other. Well, these guys cancel. So I now have W by itself. So W equals, all right, is there anything that I can cancel on the other side? Well, let's see, 3 and 2 don't have anything that's shared, right? These guys right here. So there's nothing I can do there, but 5 at least can go into both 325 and 130. So I am dividing 325 by 5. I think I will in a moment. It's always funny on videos, right? People don't see what you're doing. We can only tell you what we're intending to do. And then, whether we admit that it went the way we intended or not is an entirely different thing. So we're going to do 325 divided by 5. And that gives me 65. Okay, so 65. And then I need to do my 130 divided by 5. And that gives me 26. I don't see any other numbers, at least straight off, that can be reduced. So I'm going to check something. I am going to look at this value as well as 65. And I'm pretty comfortable with the factors of 26. So the factors of 26 are 1, 2, and 13. Well, I'm not so sure about 65. But if any one of those, the 1, 2, or 13, goes into 65, it means it can be reduced further. I know that 1 goes in. It doesn't help me any. I know 2 doesn't go in. So now I'm at 13. So let's now do 65 divided by 13 and see what we get, right? If we get a whole number, it means we can reduce. If we don't get a whole number, everything is already fully simplified. And 65 divided by 13 is actually 5. Okay, so it can reduce again. So 13 goes into 26 2 times. So that's what's left over here. And then 13 goes into 65 5 times. Notice also that I've used a combination of different colors, so it's easier for me to see what's left. So on the left-hand side, I have 3 times 5, which is 15, over, let's see here, 2 times 2. So over 4, right? So we had 3 times 5, which is the numerator, and then 2 times 2, which is the denominator. So I give myself a little more space here, and to get all of my information in, I'm finding a length, and so it is a singular unit, right, with no square or cubed, and so that is my final answer. That one is a tricky one, right, with all of the simplifying. And so I wanted to show you the strategy that I follow for actually going through those sorts of things, right? And so, having a strategy for making sure you're fully reduced is super, super important because your answers always need to be fully reduced.